Good afternoon. My name's Alistair Nottingham, and my day job is working for IBM as the lead architect for the Open Liberty project. And the Open Liberty project is commonly used by IR customers to build cloud native applications. And for the last few years, there's been kind of this assumption that people have a common understanding of what cloud native means. And a big part of that is it means microservices. But this year in particular, but growing over the last few years, has been this kind of idea that perhaps microservices uh, aren't the panacea that they were previously believed, and therefore it's a good time to sit back and think, what does cloud native really mean? Because for some people, cloud native means Spring Boot, but obviously that can't mean cloud native because you can build cloud native JavaScript applications, no problem. Um, so it's not about a particular technology per se. It's about something else. So what we'd like to talk about with you today is what does that mean? And as a starting point, I thought I'd do a quick search online and I'd go and see what some kind of key companies who sell software around cloud native have to say. And the first one I came to is VMware, and VMware are the company behind VMware virtualization and the Tanzu Kubernetes platform, but also Cloud Foundry and Spring Boot. And I thought, well, they have a long history of being in the cloud native space. So what do they say? And I found their definition interesting because it isn't saying that it's a thing. It talks about it as being an approach to building and running applications, and that it's about exploiting the advantage of the cloud computing delivery model. Now, I'm still not quite sure if I've followed what their view of the cloud computing delivery model was. But one of the things that I noticed on their definition is they have this graphic, which I'm showing here, and it shows the importance of DevOps, the importance of continuous delivery, the importance of containers, and the importance of microservice architectures. And really, it's that bottom left microservice architectures that I'm really saying, is that necessarily inexplicably linked with cloud native? So I'd read the VMware definition and I went and looked at the Microsoft one. And the Microsoft, these articles that define cloud native, they say a lot of different things. And I'm just pulling out a few points. In this one, I'm pulling out that it's about speed and agility, which I thought was a very interesting point. And I'm going to come back to that later. But you'll notice that they have this graphic, which again, I've reproduced here. And again, it talks about kind of microservices as if it's a key part of cloud native. And as my kind of final look, I went to see what Red Hat say. And Red Hat's website was actually interesting because it starts out pretty strongly saying cloud native applications are a collection of small, independent, and loosely coupled services. And whilst it doesn't say they are microservices, that description pretty much says they are microservices. Small, independent, loosely coupled, that's basically the byline of microservices. And again, later on in that page, you'll see DevOps and containers and microservices. They actually pull in APIs as the fourth one, perhaps because they view continuous delivery as a part of DevOps. But you'll notice all of these kind of companies have a similar vein, which is it's about how you develop, how you deploy microservices. The interesting thing about the Red Hat definition is right at the bottom, almost at the end, it has this sentence: you don't always have to start with microservices to speed up application delivery as part of cloud native apps. And I think that's quite important. Now, they're obviously thinking in terms of, well, some people have applications and they just want to take them off virtual machines and run them on containers, and they want this definition to kind of encompass that. But I think also it's a start. It was the first time when I really saw an acknowledgement that, microservices weren't necessarily 100% the best way to get value out of the cloud. And having read these, I decided, well, who better to look for a definition from than the Cloud Native Computing Foundation? Because, it's in their name. You would think that they would actually know how to how it defines what cloud native really means. And you'll actually notice that I've been hyphenating cloud native, and that's because one of my colleagues is kind of an English fan, and he says under proper English it should be hyphenated. And the Cloud Native Computing Foundation, and in fact, a lot of the other definitions are very inconsistent in the use of hyphen versus not. But their definition is actually quite interesting because they talk about containers and service meshes and microservices and so on and so forth, but they say those exemplify the approach. And what it's really about is empowering organizations to build and run scalable applications in the cloud. So whilst microservices are a good way to do this, with containers being a good way to do this, it acknowledges that there are other approaches that fit within this. And one of my colleagues, who I speak to on a kind of regular basis, he's been using this chart to kind of illustrate how cloud native is beyond the core architecture of how you deliver your application and services. And if you start from kind of the wrong way around, if you start from the right hand side, okay, functions as an approach to software delivery is absolutely the most cloud native thing that you could probably come up with. And the reason I say this is because in mostly and you can deploy functions on premise, but mostly people who deploying functions, they're deploying functions in a cloud, and they're paying based on usage, and how many calls to the function are made. And that doesn't work if you're running servers on premise. You don't get the kind of benefits because you have to pay for the hardware. Functions still run on software, they still run on somewhere. That still has to be factored in. And in the cloud environment, they factored that by making it, pay as you use. If you get kind of coarser grained than that, you get to microservices. And I know it kind of might seem amusing to refer to a microservice as somewhat coarser than a coarser. But you tend to have more functions and you tend to have microservices. And this is where really the industry has been trying to derive the cloud value in this microservice area. And this is the one where, whilst there's been a lot of notable successes, Spotify, Netflix, are two good examples where companies have got a lot of value out of microservices. It's also a trap. There's a continuity. There are pros and cons of all of these. And some of the early adopters of microservices have been talking about something which combines some of those microservices together to be deployed into a number of coarser grained. And these could be described in a couple of ways. Macroservices seems to be a reasonable way to describe them, where you essentially have, in this case, this diagram shows the services being broken into 3 independently deployable chunks with a set of services within them. So this is not a monolith. This is more like a couple of mini monoliths with well-defined APIs around them. And depending on your development organizational structure, this can actually provide a lot of value. And then, of course, on the, and some people might refer to this as a kind of cloud native monolith or a modular monolith. And then, of course, you have the true monolith, which doesn't really exist, where everything is encoded in a single application. And I say it doesn't really exist because I have been working in the software industry in this kind of space for almost 20 years, and very, very few people have a single monolithic application. They tend to have a whole series of monolithic applications, but the difference is that they don't have those kind of well-defined API boundaries that are exemplified within kind of all of the other architectures. And all of these could be built to be cloud native. How is an interesting question. In some cases, it's more obvious than others, but there is nothing intrinsic about these architectures that mean they can't be done in a way that's cloud native. And it's not just me saying this. There's actually quite a few people in the industry who are essentially saying one size doesn't fit all. What you build needs to be appropriate for your organization. And, some people say, monolith first. Some people, Kelsey Hightower predicts that in 2020, everyone will be doing monoliths. I'm not sure if I'm not sure I would say everyone is doing monoliths, but I think there is a growth in interest in architectures that aren't microservices, hence this talk. And interestingly, there's this tweet here from somebody at Uber, and they're moving many of our microservices to what Copy Construct calls macroservices, and that is because there is a certain scale. Too many, it sounds great to say I've got 600 microservices across 12,000 containers and I do 50 deploys a day. But we're not in the industry to compete based on how many containers we have. What we're here for is to deliver innovation and value and stability to our user base. And microservices work best in environments in environments where that's not, in some environments, but not all, essentially. And there's some interesting surveys recently that say that kind of interest in microservices is actually declining. Now, this is not a major decline. This could, this is a small decline. And if it was a decline if this Jakarta survey, this is comparing 2019 for 2020, there's a decline in microservices. It's not a particularly significant one in the survey basis. What is interesting is the huge growth in the monolith area. And it's essentially doubled the number of people responding who have an interest in the monolith area, whereas a few years ago that was considered to be something no one wanted to admit being involved in. And it's not just Eclipse that is seeing this kind of renewed interest in monolith. Jamie Coleman, who works for IBM doing developer advocacy, he did a Twitter survey, and he actually found that there was a strong interest in monoliths, and also there was a pretty strong interest in macroservices. So this kind of idea that microservices, everyone is trying to get to microservices, is perhaps no longer the thing it was a few years ago. And the big kind of key reason for this is there's been, as with when more people try to deploy and deliver microservices, more and more people fail. And this is not a problem. This is not, oh, your project failed, ha ha ha, you're a bad developer. Failure is how we learn. And failure is how we gain nuance. Not everyone can, not everyone can spend, the amount of money that some companies spend on the software engineers to build highly efficient, highly effective microservice environments. But that's been the kind of what everyone has been attempting to achieve. And there's a lot of reasons why the microservice projects fail, but there's one kind of common thread, which is the projects which fail have ended up being a distributed monolith. And what this essentially means is you have all of the kind of the negative traits associated with the distributed application. Method calls, procedure calls are much more efficient than an HTTP network trip. That's just science. That's just physics. So there are downsides to having lots and lots of microservices that need to be managed and deployed. And if you can't do that independently because perhaps you got your abstractions wrong, perhaps your domain model is wrong, perhaps your organizational structure is not set up in a way that allows you to deploy the microservices independently. Some groups who've tried to do microservices, they don't trust their regression test bucket, the contract tests sufficiently to be able to do the independent deployment. They're concerned, or they've been burned by making a change to one of the microservices and it causing an outage in another. And all of these are pointers to your microservices, the worst of all worlds, the distributed monolith, because you've got all of the downsides of a monolith and all of the downsides of a microservice, and you've got none of the upsides of either. So if microservices aren't 100% always the best way to get cloud native applications out there, why is that? And one of the things I like coming back to is Conway's law. And Conway's law effectively says, and this is the official definition on the screen, but it effectively says that your software architecture essentially will model your organizational structure. And I have seen in so many ways that this is true. And it's essentially an aspect of human nature. People who work on a single team communicate more effectively than people across two teams. If you only have to communicate with yourself, your communications is going to be very rapid and it's going to be very, very tight. If you're communicating with somebody who's in another country and another team in another organization, it's going to be much looser. And if your organization is set up in a very tight, kind of strict environment where you have a very small number of people, very small number of teams, then you're going to build software a certain way, no matter how hard you try. So, in terms of, well, what does cloud native really mean then? I like to go back to this definition from Paul Freemantle, which was in 2010. And this lines up back to some of the earlier definitions a little, but he says cloud native means it works well in a cloud environment. And what that means is that you're able to take advantage of the capabilities offered by the cloud. If you've written an application that was running on a physical hardware 15 to 20 years ago, you'd be very lucky if moving that to the cloud gives you any additional benefit other than you're just running it on somebody else's hardware. So this goes back to why are we investing in the cloud? And the reason, as Microsoft said, the reason people are investing in the cloud is for two reasons. One is they think it's more cost effective. And the second is for the promised benefits of speed and agility. And the speed and agility is really important because that's how you deliver innovation and improvements for your company, for your application, for whatever. It's not just about getting more requests a second. It's about how quickly can you update and deploy both new function as well as bug fixes. And in order to get that benefit, you need to look at multiple different things. It's not just a technology problem. And if we look at the architectures that we defined earlier as monolith, macroservice, microservice functions, in certain different criteria, they change. So and you know, there are more criteria, I'm sure, than just as shown but here, but this is just a set of them. I'm going to ignore the pricing one because traditionally, you know, people who've developed monoliths, they run in a kind of capital expenditure ways. People who run on functions are very operational expenses, but we're technology people here, so it's probably less interesting. What's more interesting is when you start going up here and you look at things like operational complexity. If you have a monolith, the operational complexity is fairly low because you have one system. If you have microservices, you have lots and lots of different independent systems that are cross-communicating that could independently go wrong. And you need to deal with that and be able to deal with that operational complexity. The other thing is, as you know, delivering modular software is a challenge. It is hard, and there's no getting away from that. And as you know, it's not relatively low as a requirement for a monolith to have good modularity. I mean, you should always have good modularity. But if you don't have good modularity in a microservice, your microservice is going to end up as a distributed monolith. And that's not somewhere you want to be. So the needs for modularity go higher. That means better upfront architecture and better isolation between your various modules. You know, monoliths network demand tends to be lower because everything is just a method or a procedure call. Functions, everything is going to be higher because everything is a network request. The other thing that I think is key to understand is how organization plays into these things as well. In general, a monolith is best developed by a small number of teams that are closely aligned and closely working together. If you have a large number of teams with a looser kind of arrangement between them, building a monolith is going to be hard. The same thing goes with microservices. If you have a small number of teams, there'll be a point where they can't manage that many microservices anymore because there are just too many for the teams involved. And these should all factor into how we think about architecture and how we choose an architecture for any particular application. When we think about some of the characteristics of cloud native, and this is by no means a exhaustive list, the things that we're looking for, I think, are quickly creating and connecting new instances. The repeatability, so it's very easy for you to redeploy in case of failure or prove that a change hasn't caused a regression or scale up and scale down. Loose coupling between your discrete systems, whether you've got a set of monoliths communicating or hundreds of microservices, is very important. Resiliency for failure, so the ability to cope with the downstream service going away, as well as having a good, quick time to recovery. And none of these say you have to have a microservice. It could all be applied using macroservices or otherwise. At the Eclipse Foundation, we're working on a number of technologies that fit into this space. There's Jakarta EE, which is a rebranding of Java EE. It's traditionally been viewed as being the mainstay of a monolith, but the APIs it provides, they're tried and tested, and there is absolutely no reason why they can't be used, and many people are using them for building microservices. Where Jakarta currently falls down a little bit is the ability to integrate it within some of these Kubernetes and container-based environments. And that is partly where MicroProfile is coming in to try and provide those additional APIs on top of Jakarta EE to tie it into those cloud native environments. And the combination of MicroProfile and Jakarta EE is a very powerful cloud native programming model. If you want to know more about the technologies in MicroProfile and Jakarta EE and how you could use them to build cloud native applications, the Open Liberty project team that I lead, we've built a bunch of guides. They all use Liberty, but what you learn could be applied to another runtime if you don't want to go into production with Liberty. And with that, thank you very much for attending this talk, and I hope it's given you some food to think about whether or not microservices are the right project for you moving forward. And now I can take questions.
Hi, so I've got a couple of questions from the talk. The first one is, would you say that GraphQL is more cloud native friendly over typical REST interface calls? And I don't think I would define GraphQL as being more or less cloud native. I view them as kind of complementary. You'd use them in slightly different scenarios, but both have a place within a cloud native domain. So GraphQL is very good when you've got a complex data model that's accessible via a HTTP request, but you don't need all of the data at any one time. So it's very good at being efficient on the network client hop. But if you've got a relatively simple API, then REST would just be fine. And if the data that's being transmitted is pretty much always going to be used, then I don't see a huge reason why you would use GraphQL. So I would say it's less about whether or not that API is more or less cloud native friendly. It's more about the data architecture of your application. Obviously, you want to minimize the amount of data that's transmitted over the network to just what is required. So that's where GraphQL does frequently come in. The second question I have is, when microservices are more tightly coupled, does this lend itself to taking a macroservice approach? And I would say absolutely. If you've got tight coupling between the microservices, you're really bordering into the territory of distributed monoliths. You might be able to manage it if it's a small number, but anytime that you find yourself being forced to deploy updates to microservices in combination, it's invariably a pointer to it not being a microservice, but a distributed monolith. And in those kind of situations, from a management perspective, it's probably better for you to merge them into a single microservice, because then you can get compile time checking, and you can get and other things involved in those interactions as well. And the third question I had is it valid to consider creating a monolith for the cloud from new? And I would say yes, it absolutely is valid to consider creating a monolith. There's a, depending on what you're building, it may be that the easiest way for you to go is to try and create a modular monolith, a well-defined monolith, which could then be decomposed later into microservices. So think of it in terms of you build a monolith because that's the most effective way to be efficient up front, and then but design in a way that allows you to refactor into macroservices or microservices over time. And I think that's all the time I have. Thank you very much for coming to my talk.